everyone, how are you doing today? I'm so glad to be here today. I'm Lee Chai Mei from Sekolah Menengah Teknik Tuanku Jaafar. Today, we are going to learn about algebraic expressions and laws of basic arithmetic operations. Please prepare your stationeries and notebook. Are you ready? Let's begin our lesson. By the end of today's lesson, you should be able to perform addition and subtraction of algebraic expressions involving expansion and factorization. Boys and girls, you have learned this term algebraic expression in Form 1. Can you recall what algebraic expression is? Well, algebraic expression is an expression which is made up of variables and constants, along with algebraic operations such as addition and subtraction. In mathematics, a constant is a specific number or a symbol that is assigned a fixed value. In other words, a constant is a value or a number that never changes in expression. A variable is a quantity that may change within the context of a mathematical problem or experiment. We normally use a single letter to represent a variable. Expressions are made up of terms. A term is either a single number or a variable, or numbers and variables multiplied together. So, what is an algebraic term? Algebraic term simply means the product of a number with one or more variables. For example, 2x is an algebraic term. Before looking into the addition and subtraction of algebraic expression, we should be familiar with these two important terms, which are expansion and factorization. For instance, when we expand the product of x plus 1 and x plus 1, the answer is x squared plus 2x plus 1. When we factorize x squared plus 2x plus 1, the answer is in bracket x plus 1 bracket x plus 1. Hence, factorization is the reverse process of expansion. It's pretty simple, right? Today, we will be looking into addition and subtraction of algebraic expressions involving expansion and factorization. Before we start, let's recall the golden rule in mathematics, which is called BODMAS. What is BODMAS? I'm sure this sounds familiar to you. B stands for bracket, O stands for order, for example, square or cube numbers. D stands for division. M stands for multiplication. A stands for addition. And S stands for subtraction. Well, this rule helps us to determine the sequence to solve a mathematical expression. In simple terms, we will have to follow this BODMAS sequence starting from bracket, then order, then division or multiplication, whichever comes first, and lastly, addition or subtraction, whichever comes first. Without further ado, let's start our mission of discovering algebraic expressions. Let's see our first example. We can see that in this example, we can expand negative 2 multiplied by in bracket 4x plus 5. Here, we will write 2x squared minus 2 multiplied by 4x, which is 8x, and 2 multiplied by 5, which is 10. Therefore, we will obtain 2x squared minus 8x minus 10. Next, can you tell me the common factor of 2, 8, and 10? You are right. The common factor is 2. Hence, we factorize each term by 2. 2 bracket x squared minus 4x minus 5. Here, we have to factorize x squared minus 4x minus 5. For x squared, we know it is x times x. Let's look at negative 5. We need to find two numbers multiplied to negative 5. It's simple. 1 times negative 5 or negative 1 times 5. Well, to get this right, we add up the two numbers to get negative 4. Therefore, we put a negative sign in front of 5 because the sum of 1 and negative 5 equals to negative 4. By referring to the table, the factorization is the product of x plus 1 and x minus 5. Hence, the answer is 2x plus 1, x minus 5. Let's look at example 2. Notice the bracket in the question. We can start off by expanding the algebraic expression. 4k multiplied by k minus 2. We will obtain 4k squared minus 8k. Hence, the expression is 4k squared minus 8k minus 5. Next step, we can factorize the algebraic expression of 4k squared minus 8k minus 5. For 4k squared, there are two possibilities: 2k times 2k or k times 4k. Let's use trial and error method. 2k times 2k. Let's look at 5. Same as the previous question, 5 times 1. Well, to work this out, we have to figure out how to get negative 8. For example, if I place the negative sign on 5, 2 times negative 5 equals to negative 10. And 2 times 1 equals to 2. The sum of negative 10 and 2 is negative 8. By referring to the table, the factorization is the product of 2k minus 5 and 2k plus 1. And therefore, we will get 2k minus 5, 2k plus 1. You have looked at two examples of operations involving algebraic expression. Now, we will move one level up. We will be looking at examples of operations involving algebraic fractions. Algebraic fraction is a fraction where the numerator or denominator or both consists of algebraic expression. For example, x over 2, 5 over 2y, p minus 1 over q. For an operation involving algebraic fractions, we must ensure that when adding or subtracting algebraic fractions, the denominators of each algebraic fraction are the same. Let's look at this example 3, which is an operation involving algebraic fractions. Remember, we have to ensure that the denominators are the same. Here, the denominator or the first term is 2x, and the denominator of the second term is also 2x. Since the denominators are the same, we can carry on with the subtraction of the numerators. Y minus 5y equals to negative 4y. Hence, we will get negative 4y over 2x. We can simplify this. Therefore, the answer is negative 2y over x. From the example above, we clearly understand that we have to identify the denominator of each fraction before adding or subtracting algebraic fractions. For case 1, if all of the algebraic fractions have equal denominator, we can directly add or subtract the numerator. For case 2, if the algebraic expressions have different denominators, we have to first equate the denominators of each algebraic fraction. Only then we add or subtract the numerators. Let's look at example 4. Notice that the algebraic fractions have different denominators. Remember, we have to first equate the denominators of each algebraic fraction before adding the numerators. Let's start with the first step, equating the denominators of 4y and 2y. We can see that one of the denominators is the multiple of the other denominator. We can easily equate them by multiplying 2y with 2. The denominator multiplied by 2, the numerator also multiplied by 2. Hence, we will obtain an equal denominator, which is 4y. Subtract the numerators, 4 minus 2. Here, we will get 2 over 4y. We can simplify this fraction. The final answer is 1 over 2y. Remember, boys and girls, we have to identify the denominator of each fraction before adding or subtracting algebraic fractions. Let's look at example 5. For this example, the denominator is not the multiple of the other denominator. However, when we look carefully, the denominators are common factors. So, how do we equate 4p and 6p? That's right! We can use LCM, or in full is called lowest common multiple. Divide each term by the common factor, 2p consecutively. The LCM of 4p and 6p is 2p times 2 times 3. Which is equal to 12p. Let's work on the denominators first. We have to convert the denominators to 12p. How do we convert 4p to 12p? Excellent! First, multiply 4p by 3 for denominator and multiply 1 by 3 for the numerator. Next, multiply 6p by 2 for the denominator and multiply 4 by 2 for the numerator. For the first algebraic fraction, 1 multiplied by 3 equals 3. 4 multiplied by 3 equals 12p. The first fraction is 3 over 12p, followed by 4 multiplied by 2 equals 8. 6p multiplied by 2 equals to 12p. The second fraction is 8 over 12p. Well, now we can see that the denominators are the same. We can add the numerators, 3 plus 8. The final answer is 11 over 12p. Boys and girls, how are you doing so far? Let's try to do the following questions. Write the answer in your notebook. Let's do question 1. First, let's check the denominator of the algebraic fraction. Both of the fractions have equal denominator, which is 5q. Well, it's simple. We can proceed with the numerators. P plus 3 subtract P minus 5. Be extra careful when there is a subtract symbol in front of a bracket. Therefore, we will get P plus 3 minus P plus 5 over 5q. Group the like terms. P minus P plus 3 plus 5. What did you get for the final answer? Great! 8 over 5q. Let's proceed to question number 2. First, let's check the denominator of the algebraic fractions. How do we equate the denominators? First, we perform the common factor for the denominator, 6v. Then, multiply 3 by 2v for the denominator and multiply 3u by 2v for the numerator. Next, multiply 2v by 3 for the denominator and multiply 3v by 3 for the numerator. So, 3u multiplied by 2v and 3v multiplied by 3. For the denominator, 3 multiplied by 2v equals 6v. For the numerator, 3u multiplied by 2v equals 6uv plus 3v multiplied by 3 equals 9v. Look at the algebraic expression in the numerator. The common factor is 3v. Therefore, we factorize 3v in bracket 2v plus 3 over 6v. Simplify the fraction. What is your final answer? Well done! The final answer is 2u plus 3 over 2. Let's do question number 3. This is our last question for the lesson today. First, let's check the denominator of the algebraic fractions. 4r and 14rs. How do we equate the denominator? Fantastic! We can use LCM. Divide each term by the common factor 2s consecutively. The LCM is 2r times 2 times 7s. The answer equals 28rs. Now, let's work on the denominators first. We have to convert the denominators to 28rs. How do we convert 4r to 28rs? Great! 4r multiplied by 7s is 28rs. Then, multiply r minus 1 by 7s for the numerator. Next, multiply 14rs by 2 for the denominator and multiply 7s by 2 for the numerator. For the numerator, r minus 1 multiplied by 7s equals 7rs minus 7s. Then 7s multiplied by 2 equals 14s. We can simplify negative 7s minus 14s equals negative 21s. Hence, the expression is 7rs minus 21s over 28rs. Look at the numerator. Can you tell me the common factor? The common factor is 7s. Therefore, we factorize 7s in bracket r minus 3 over 28rs. Simplify the fraction. What is your final answer? Well done! The final answer is r minus 3 over 4r. Congratulations to those who have successfully answered the 3 questions correctly. You have done a great job. We have come to the end of the lesson. Now, you are able to perform addition and subtraction of algebraic expressions involving expansion and factorization. I hope you enjoyed today's lesson. Thank you for joining me here today. Goodbye!